My name is Christoph Schuber. I'm in the Solaris security organization, and Glenn Faden and I have put together a presentation we presented here at Oracle Open World entitled Protecting Oracle Applications with Built-in Solaris Security Features. After talking to some of the Oracle staff in the database security group, we realized that the Oracle database installations for Unix are pretty much uniform across all the various different Unix operating systems. That meant for us that the database is not actually taking advantage of some of the really nice security features that are built into Solaris. So as a case study for the last couple of weeks, we put together a system where we're really taking advantage of the Solaris security features. So in some sense you can think of the database being hardened against all kinds of attacks. So what we have running here is actually on a server in the rack behind me on an x5220 machine, so a Spark server, multiple CPUs, an Oracle database installation of 10G2, and we secured it by basically applying the technologies we have for user rights management, for process rights management, for service management, so SMF. Then we used containers for containment of the processes and damage containment possibly, and also auditing. So in this booth here, the Sun booth at Oracle Open World, we're demonstrating a subset of these interactively that we have installed on the system. So if we pan over here to the screen, I can show a few of these. So what you see here is a VNC session running on this front end to the server in the background, and you see two windows on the screen. The first one up here entitled Oracle $, and the second one entitled JDO %. So traditionally, the installation for Oracle allowed for a user called Oracle to administer the database, start the database, stop the services, look at various different processes. We've changed that ever so slightly in Solaris 10, where we're basically saying administrators now don't log in into this shared account Oracle, but they log in as themselves. So for example, JDO here, the user ID really is JDO. But as the user JDO, you can log into a number of different roles, and one of these roles is the role Oracle. So up here we're logged in as user JDO, but SU to the role Oracle. The big advantage here is that multiple administrators now don't share a single login ID, but they all are accountable for their actions as the individuals that they are, yet they still have the power to execute processes under the user ID, under the role Oracle. Now, we played another trick here with respect to user management, and that is that in the policy.conf file, we set the default privileges for a user to be slightly less than what a normal user can traditionally do in Unix. So it's not just the basic privilege set in Solaris now, it's basic without proc info. That means if you list all processes as user JDO, you see only the processes that belong to this user JDO. You see no other processes on the system. You see nothing from user root, and in particular you see nothing from the role Oracle. If I run the same command over here in this other window, I see as role Oracle, I see only the Oracle processes. This is very nice. Also, the privileges that are associated with this role Oracle now are the basic set without proc info. Now, the individual processes that are running here that are part of the Oracle database, however, if we just look at, for example, the privileges for this process ID that I just highlight here, you see that the effective set is actually basic. That means slightly more than what the user has. The big advantage here is that even though you're logged into the role Oracle, you cannot look at anything process specific for a process that was started through SMF as part of the database, you get a permission denied because the role oracle has slightly fewer privileges than the process that's actually running over here. In addition to that, I said earlier that there is full accountability associated with what the individual users do. So every command I typed into this window up here that we just saw, so the trust command, for example, or the ppriv command, they were actually monitored over in the global zone in this window here. And in order to show this that it's actually live and running, I'm just going to go back here and type yet another command. Let's just say something really silly like ls-l, and I switch quickly over to the other side, and you will see that within the next few seconds the Netscape window here will update and display the next audit record for this ls-l that I executed earlier. There you see it happening. And if you look carefully at what's actually being audited here, you see the subject, that the user ID is actually JDoe, although I executed it as the role Oracle. So the real user ID is Oracle, but it's associated with the audit user ID of JDoe. So we know exactly who executed this program right now. And then we see the path in which it was executed. We see the actual executable, ls, as well as all the arguments. So we could demo a few more things, but I think I'll leave it at this now because it gives sort of a flavor of how we use the various different technologies in Solaris to secure an Oracle database installation. So more information can be acquired by emailing either Glenn or me, so glenn.faden@sun.com or christoph.schuba@sun.com, or by simply looking at our blogs. So blogs.sun.com/schuba or blogs.sun.com/gfaden. Thank you.